Welcome back, everyone, for another deep dive. This time, we're going to be taking a look at how scientists track asteroids and how they figure out, if they're going to hit the Earth or not.
Right.
And we're going to be looking at two recent articles specifically about an asteroid called 2024 YR4.
Okay.
It's been in the news a little bit lately because there is a small chance, but a chance that it could hit Earth in 2032.
Hmm.
But what's really fascinating is that the more information we get about it, the risk level might actually appear to go up before it goes down.
Right.
And there's a really interesting scientific reason for that. So we're going to unpack all of that today.
Yeah, definitely. The more we learn about these objects, the more interesting they get, I think.
Yeah, I find it fascinating that they can even determine the path of an asteroid because, initially it's just a dot of light. It's like
Wow.
trying to map a cross-country road trip based on a single glimpse of a car on the highway.
Right.
Like, how do they even begin to assess the risk with so little information?
Well, it all starts with multiple observations, right? Like you said, you can't determine a car's route from just seeing it.
Mm-hmm.
Once you get to track these dots of light over time and to really understand, are they on a trajectory that could be a threat to us?
Yep.
And this initial phase is marked by uncertainty, which we visualize as a risk corridor.
Okay.
So imagine sort of a wide path that the asteroid might take.
Mm-hmm.
And as we collect more observations, that corridor narrows. But here's the catch. Even as it narrows, it might momentarily overlap with the Earth's orbit.
So the more we know, the riskier it seems, at least at first.
Exactly.
Okay, that seems completely counterintuitive.
Yeah.
Tell me more about 2024 YR4.
So 2024 YR4 was discovered late last year on December 27th, 2024 by the ATLA's telescope in Chile,
Okay.
and quickly grabbed the attention of the scientific community because those early observations indicated that small chance of impact in 2032 you mentioned.
Yeah.
And as a result of that, it landed right at the top of the European Space Agency's risk list.
Wow.
And they estimate that this asteroid is somewhere between 40 and 100 meters wide.
That's pretty big.
Yeah, that's definitely large enough to cause significant regional damage if it were to hit. And that's why it's been assigned a level 3 on the Torino Impact Hazard scale.
Okay, level 3 sounds serious. What does that actually mean in terms of risk? Should we be worried?
Well, it means that 2024 YR4 warrants close attention and continuous monitoring.
Okay.
But it's not a reason to panic just yet. The Torino scale helps us to categorize, how threatening is this impact potentially.
Right.
It goes from 0, which means no hazard at all, up to 10, which would be a certain collision with global consequences.
Okay.
Level 3 signifies a close encounter,
Okay.
a chance of collision capable of causing regional damage,
Yeah.
but not global.
So cause for concern, but not time to, run for the hills yet.
Exactly.
What I find interesting is that as of just a few days ago, January 29th, 2025, the probability of impact is estimated at 1.2%,
Right.
which seems low, but it's actually consistent with estimates from both NASA and NEODIS, which is a similar monitoring system used by the European Space Agency. Is this where that whole risk corridor idea comes into play?
Absolutely.
Yeah.
As we gather more data,
Yeah.
that corridor might initially appear to intersect more directly with Earth.
Okay.
It's not that the asteroid is suddenly changing direction.
Right.
It's just that our understanding of its trajectory is becoming more precise.
I see.
It's kind of like if you look at two lines and they seem to intersect from a distance.
Yeah.
But as you get closer and you get a clearer perspective, you realize they're actually running parallel to each other.
Oh,
A
interesting.
similar concept here.
Okay, so it's like gaining a sharper focus on a blurry image.
Right.
Sometimes things look scarier before they come into clarity.
Exactly.
What I find amazing is that a 1.2% chance of impact is enough to mobilize the international community.
Yeah.
Our sources mention that 2 UN-endorsed groups have been activated to monitor 2024 YR4, the International Asteroid Warning Network, or IAWN, and the Space Mission Planning Advisory Group, known as SMPAG.
Yes.
What's the difference between these two groups?
So IAWN is all about coordination. It acts as this central hub for gathering and sharing data about potentially hazardous asteroids.
Okay.
They coordinate observations from all around the world, and they develop strategies to prepare for a potential impact.
So they're making sure that everyone's on the same page and prepared if things take a turn for the worse.
Exactly. SMPAG, on the other hand, focuses on what we could actually do to prevent an impact.
Okay.
So they delve into the specifics of potential mitigation efforts, like sending a spacecraft to deflect the asteroid if the risk remains high.
That's fascinating. Are they considering any specific missions for 2024 YR4 yet?
It's still a little too early to say,
Yeah.
but they are actively monitoring the situation. One of the challenges is that 2024 YR4 has a very elongated orbit,
Okay.
which makes it tricky to track. And to add to that, it's actually going to start fading from view in the next few months.
Wait, so we're going to lose sight of it?
Yeah.
For a little while. What happens then? Do we just sit and wait for it to pop back into view?
Well, not exactly. The European Space Agency is coordinating observations with increasingly powerful telescopes, including the Very Large Telescope in Chile.
Wow.
They're really trying to get as much data as possible before it fades. But even if we can't completely rule out an impact before it disappears, the good news is that it will be observable again in 2028.
So we have a bit of a cosmic cliffhanger on our hands.
We do.
We have to wait and see what happens when 2024 YR4 returns to view. This must be a pretty common challenge in the world of asteroid tracking.
It is. Detecting these objects, especially those with unusual orbits or those that don't reflect much sunlight, can be remarkably difficult. That's why dedicated asteroid surveys like the one conducted by the ATLA's telescope are so important.
It's like trying to find a needle in a haystack, but the haystack is the entire solar system.
Exactly. It requires sophisticated technology and constant vigilance to make sure we're prepared for whatever comes our way.
Absolutely. Wow, it really is amazing to think about the sheer scale of, what we're talking about here. The vastness of space and these, chunks of rock just hurtling through it, some on a potential collision course with Earth.
Yeah.
It really reminds me of how much we rely on science to make sense of the universe and, keep us safe.
It's a humbling reminder of our place in the cosmos, I think. We often take for granted the intricate systems that are protecting us from these celestial wanderers.
Absolutely. Before we go any further, can we circle back to that risk corridor concept?
Sure.
It seems pretty fundamental to how scientists are assessing, potential asteroid threats.
Yeah, you're absolutely right. It's a core principle in asteroid tracking.
Yeah.
When we first spot an asteroid, we only have a limited amount of information about its path.
Right.
And so that's where that risk corridor comes in. It represents the range of possible trajectories based on those initial observations.
So it's kind of like if you were to draw, a wide path on a map,
Right.
indicating all the potential directions that the asteroid could be heading.
Exactly. And if any part of that path overlaps with Earth's orbit, well, then that gets our attention.
Right, of course.
However, as we gather more observations, that corridor starts to narrow, and we get a clearer picture of the asteroid's actual trajectory.
Okay, so we're essentially zooming in on that map,
Exactly.
getting a more precise view of the asteroid's path. But you mentioned earlier that sometimes as that corridor narrows, it can momentarily seem to point more directly at Earth.
Right.
It's like things get a little bit scarier before they get better.
That's a great way to put it.
Yeah.
The risk corridor is dynamic. It evolves as our data improves.
Hmm.
And it's important to remember that even if that corridor momentarily appears to intersect with Earth, it doesn't necessarily mean the risk has actually increased.
Okay.
Often it's just a reflection of our understanding becoming more refined.
This reminds me of those optical illusions where your perception shifts as you look at the image from different angles.
Right.
What initially seemed like, a collision course might actually turn out to be a near miss once we have all the pieces of the puzzle.
Precisely. And this really highlights why it's so crucial to rely on scientific expertise. The scientists who specialize in asteroid tracking, they have the knowledge and the tools to interpret this data accurately and to make informed assessments about the actual risk.
It's a good reminder to trust the process.
Yeah.
And, avoid jumping to conclusions based on preliminary data.
Right.
Speaking of expertise, you mentioned earlier that 2 UN-endorsed groups, IAWN and SMPAG, have been activated to monitor 2024 YR4.
Yes.
I'm curious, what does that activation actually look like in practice? Are they constantly monitoring this asteroid? What are they actually doing behind the scenes?
It's an incredible global collaboration. IAWN, the International Asteroid Warning Network, plays a central role in coordinating these efforts.
Okay.
They bring together observatories and scientists from around the world, ensuring this constant flow of data and analysis on potentially hazardous asteroids.
So they're like the central command center,
Yeah.
making sure all the information is shared and everybody's working together.
Yes.
Exactly.
They act as this clearinghouse for observations, making sure that all the data is carefully analyzed and interpreted. And then they communicate their findings to governments and space agencies, providing timely alerts and guidance,
Okay.
if necessary.
And what about SMPAG, the Space Mission Planning Advisory Group? What are they focused on right now?
Well, while IAWN is focused on monitoring and assessment, SMPAG takes a more proactive approach.
Okay.
They start brainstorming potential mitigation strategies, essentially coming up with plans for what we could actually do to prevent an impact should the need arise.
So they're the ones working on, like, the Armageddon scenarios we see in movies.
Exactly.
Figuring out how to deflect an asteroid if it really is on a collision course with Earth.
Right. Of course, the reality is far less dramatic than Hollywood would have us believe.
Right.
SMPAG considers a whole range of options, from things like using kinetic impactors to just nudge the asteroid slightly off course, to exploring more complex techniques like gravity tractors or even nuclear explosives as a last resort.
Nuclear explosives, that sounds a bit extreme.
It is. It's definitely a last resort,
Yeah.
and a decision that would not be taken lightly. The use of nuclear devices in space would involve a whole host of complex, technical and political and ethical considerations.
Of course.
However, it's important to have all the options on the table,
Right.
especially when we're dealing with a potential threat to our planet.
Yeah, that makes sense. It's reassuring to know that these experts are exploring all avenues to protect us.
Yeah.
What I find interesting is that we often, associate asteroids with danger and disaster.
Right.
But our sources mention that they're not just potential threats, they're also incredible, valuable resources.
That's a crucial point. Asteroids are like these time capsules from the early solar system,
Oh, wow.
offering invaluable scientific insights. And beyond that, they contain this treasure trove of resources, precious metals, water ice, and even platinum group metals that are incredibly rare on Earth.
So we're talking about a potential gold rush, but in space.
Exactly.
What are some of the challenges and opportunities associated with asteroid mining?
Well, the challenges are significant. We're talking about operating in this harsh and unforgiving environment, millions of miles away from Earth.
Yep.
Extracting resources from an asteroid and transporting them back to Earth, or even utilizing them in space, requires advanced technology and massive investment.
It sounds incredibly difficult and expensive.
It is, but the potential payoff could be immense.
Yeah.
Imagine having access to this virtually unlimited supply of rare earth metals.
Wow.
Or even using water ice from asteroids to create fuel depots in space,
Sure.
enabling us to travel further than ever before.
It's like opening up this whole new frontier, not just for resource extraction, but for, expanding our presence in space.
Yeah,
This makes the work of IAWN and SMPAG even more important.
absolutely.
As we venture further into space, we need to be prepared for anything.
Planetary defense and space exploration go hand in hand. The more we learn about asteroids, the better equipped we'll be to both protect our planet and unlock the incredible opportunities that these celestial objects offer.
It really is a remarkable blend of scientific endeavor and technological innovation and international cooperation.
Yeah.
Before we wrap up this part of our deep dive, I want to touch on something we mentioned earlier, the public's perception of asteroid risk.
Yeah.
Knowing that the perceived risk of an asteroid impact can fluctuate as we gather more data. How do you think the public reacts to this information?
It's a fascinating aspect of this whole discussion.
Yeah.
Knowing that the risk can appear to go up as we get more information.
Right.
How does that affect the way people perceive the threat?
Well, I think there's a natural tendency for people to, latch onto those initial reports of a potential threat,
Right.
especially when the headlines are screaming about, some kind of doomsday scenario.
Yeah.
It's easy to get swept up in the drama without necessarily understanding the nuances of asteroid tracking.
That's true. And when you add in the fact that the perceived risk can unusually go up,
Right.
can create a lot of unnecessary anxiety. And it's a real challenge for scientists and science communicators to convey this complex information
Yeah.
in a way that's both accurate and accessible to the public.
We're back to that balancing act.
Ah.
Ensuring accuracy without causing undue alarm. How do we strike that balance, especially when we're dealing with a topic that's inherently sensitive and, prone to sensationalism?
Yeah, it really is a challenge.
Yeah.
How do we convey the seriousness of, the situation without causing widespread panic?
It's a delicate balance.
Yeah.
We have to be transparent about the risks, but without resorting to sensationalism, One approach is to really focus on the science behind asteroid tracking, explain the process of how we actually refine our understanding of an asteroid's trajectory over time.
So instead of just throwing out, percentages and alarming headlines,
Right.
we need to explain the context and the methodology and the uncertainties involved.
Yeah.
It's about empowering the public with knowledge
Yeah.
rather than feeding into fear. Exactly.
Hmm.
We also need to highlight the incredible work that's being done by scientists and engineers around the world. Planetary defense is a rapidly advancing field.
Right.
We're constantly developing new technologies and strategies to detect, track, and even deflect potentially hazardous asteroids.
It's a reminder that while the threat is real, it's not insurmountable.
Right.
We have, brilliant minds working on this, and we're getting better at protecting our planet all the time. What are some of the most promising advancements in planetary defense that you're excited about?
Well, there are several cutting-edge technologies on the horizon. One that I find particularly fascinating is the concept of a gravity tractor,
Okay.
which involves using a spacecraft's own gravitational pull to ever so slightly alter an asteroid's trajectory over time.
It's like a cosmic tow truck, gently nudging the asteroid off course.
That's a great analogy. Another promising area is the development of kinetic impactors.
Okay.
Essentially high-speed projectiles designed to collide with an asteroid and alter its momentum.
It sounds like something straight out of a sci-fi movie.
It does, but the technology is becoming increasingly sophisticated. We're also seeing advances in laser ablation techniques, where focused laser beams could be used to vaporize a small portion of an asteroid's surface.
Interesting.
And that would create this jet plume that would actually act as a thruster, slowly pushing it away from Earth.
Wow. It's incredible to think about how we're harnessing, cutting-edge technology like that to protect our planet from these cosmic threats.
Yeah, that's really remarkable.
But beyond planetary defense, there's this whole other aspect to this conversation, the potential of asteroids as valuable resources. We touched on this a little bit earlier, but I'd love to kind of delve a bit deeper. What are some of the most sought-after resources that we could potentially extract from asteroids?
Well, the possibilities are vast. Asteroids are rich in precious metals like platinum, gold, iridium. They also contain water ice, which could be used for things like life support systems, radiation shielding, and even broken down into hydrogen and oxygen for rocket fuel.
What?
Imagine having refueling stations in space, allowing us to travel further than ever before.
Yeah, it's like turning asteroids into these cosmic gas stations.
Right, exactly.
It would revolutionize space exploration. What are some of the companies and organizations that are kind of leading the charge in asteroid mining?
Well, several companies are emerging as pioneers in this field. Planetary Resources, Deep Space Industries, and Asteroid Mining Corporation are just a few examples. They're developing innovative technologies and spacecraft specifically designed for asteroid prospecting and resource extraction.
Wow. So it's exciting to see the private sector stepping up and investing in this frontier. But with all this talk about, mining asteroids and harvesting their resources, it raises some interesting ethical and legal questions.
Yeah.
Who owns these celestial bodies? How do we ensure responsible and sustainable resource extraction?
Those are crucial questions and ones that are still being debated. The Outer Space Treaty of 1967 provides a framework stating that no nation can claim sovereignty over celestial bodies. However, it doesn't explicitly address the issue of commercial resource extraction.
So it's a bit of a legal gray area.
It is, and that's why international collaboration and dialogue are essential as we move forward. We need to establish, clear guidelines and regulations to ensure that asteroid mining is conducted in a responsible and sustainable manner, benefiting all of humanity and preserving these celestial bodies for future generations.
Right. It's a reminder that as we venture further into space, we need to bring our ethical compass with us.
Absolutely.
We have a responsibility to explore and utilize these resources in a way that's both beneficial and sustainable.
Well, it's been an incredible journey exploring, the world of asteroid tracking, from the scientific intricacies to the broader implications for planetary defense and resource utilization.
Yeah.
It's clear that asteroids are far more than just potential threats. They're fascinating objects that hold clues to our past resources for our future and endless possibilities for scientific discovery and technological innovation. I completely agree. It's been a pleasure sharing these insights with you, and hopefully our deep dive has sparked your curiosity and given you a new appreciation for these celestial wanderers.
And to our listeners, we encourage you to explore further. Check out the show notes for links to learn more about asteroid tracking, the Torino scale, the latest advancements in planetary defense, and the exciting field of asteroid mining. Keep looking up.